So, coordination compound that are also known as a complex compound because in this case, metal is attached to either neutral molecule or negative ion. Both are possible. Okay, this anion or neutral molecule is known as ligand. Correct. And here, electron are shared between the neutral or anion molecule and metal. Basically, ligand and metal are connected through the covalent
सर
bond.
लिखना है ना नोट्स.
हाँ, of course लिखना है. हाँ, so ligand and metal are connected with each other with the help of a bond in which ligand is donating both electron and metal is accepting. This concept is extremely important even in your crystal field theory. Okay. We have many compounds that contain a coordination compound. Example, chlorophyll is a coordination compound of magnesium. Hemoglobin is a coordination compound of Fe2 positive ion, and vitamin B12 contain cobalt. So all these are the example of the coordination compound that we use in the daily life. Very first time there was a scientist who is known as Werner told us about the coordination compound. Okay. He was trying to study physical and chemical property of the coordination compound, and he came up with the concept that there is a primary valency and secondary valency. You already know about the primary valency. Primary valency like this charge. Example, if you see aluminum AlCl3, you know aluminum have three positive charge, so valency will be 3. Or MgOH twice. Magnesium have two positive charge, so primary valency is 2. Correct? But secondary valence, in this case, primary valency is always satisfied by the anion, negative ion. But secondary valency can be satisfied by anion or neutral molecule both. That is a special thing. And that's why we have secondary valency only in this chapter. Secondary one. In any other chapter, we have only primary valency. Okay. Example here. Chromium is attached with a 3 chlorine, so 3 valency. 2 chlorine, 2 valency, 2 chlorine, 2 valency. So there is no problem in the primary valency. Whatever is the atom it attached with, that is the valency. But secondary valency is interesting to do. Example, if you take any of these compound, remember cobalt will always have 6 molecule. Okay. Example, in first situation, this is first, second, third, and fourth. So if you have already 6 ammonia, then bond will be completed and 3 chlorine will be outside. These 3 chlorine will give 3 AgCl. So this 3 AgCl is the primary valency. Cobalt is showing 3 primary valency. Secondary valency is 6. In B compound, you have only 5 ammonia. Sorry, you have 5 ammonia. It means 1 chlorine will be inside because there should be total 6 molecule. It means 2 chlorine outside. So only outside chlorine will give you the molecule like AgCl2.
So,
Yes, Anvita.
primary valency is basically oxidation number and secondary valency is coordination number, right?
Yes. Primary valence is the oxidation number and secondary valence is the coordination number. Okay. And coordination number is coordination compound. So in this case, cobalt secondary valency is 6. Primary valency in every situation is changing. Depend upon how many AgCl will settle down when it react with the Ag. Okay. So here second, what is the secondary valency? All the molecule present with the metal in the coordination sphere. This bracket is the coordination sphere. In this you have metal. Example here it is cobalt. Anything other than the cobalt will be secondary molecule or ligand, or this molecule will form secondary valency. Okay, molecule present in the coordination sphere other than metal form secondary valency. Okay, Jordan, if you look at this, it makes sense ki 3 chlorine is outside primary valency. That's why 1:3. 2 chlorine outside 1:2. In this situation, you have 1:1 ratio. But why it is given? If both compound are exactly same, their electrolyte ratio is also same, then why do we have this?
Because the coordination compound doesn't dissociate in
No,
solution.
they have different color because of their R isomer, but different maybe geometrical isomerism or optical isomerism. Correct?
Yes, sir.
Because of the isomerism. Though everything looks similar, but when we see the property color, it is different. It means though their formula looks same, but they have some difference. That's why different color. Okay. So this is the Werner theory. Werner theory say that in a coordination compound, you have two type of valency. Valency is also known as linkage, primary and secondary. Primary valency is ionizable, means it have ion. As Anvita you mentioned, primary oxidation state is primary valence, and it is satisfied only by the negative ion. I said already.
सर
Secondary valency is non-ionizable. Yes, Pratigya.
सर मैं लिख नहीं पा रही हूँ.
It's okay. जितना लिख पा रही हो उतना लिखो. Whatever you can write, do write. Write in the short.
ओके सर.
Okay. Secondary valency is non-ionizable because whether you take chlorine inside, example here, if you take chlorine inside in this compound, so chlorine will not be ionizable. It is like neutral atom inside the bracket. Inside the bracket, everything is neutral atom. That's why non-ionizable. That's why non-ionizable. Okay. And it can be satisfied by neutral molecule or negative. Both is possible. So secondary valence is equal to the coordination number, and it is fixed for a given metal. Example, cobalt, usually you will see 6 coordination number. For platinum, you will usually see 4. Mostly it is fixed for a given. And last, in this secondary valency or secondary linkage, we talk about the characteristic special arrangement, means 3D arrangement. It means stereoisomer. How in the space in 3D atom are arranged differently. We will discuss this in the isomerism. Don't worry. Okay. So example, if you have two compound, both are octahedral, still their arrangement can be different. Okay. Different arrangement of the 3D compound is known as coordination polyhedral. And in bracket, whatever you have is the coordination entity or complex, not so important, nobody going to. Ion present outside is the counter ion, and there could be different type of shape. Example, I'll show you based on the example. Yes. Look at this. Whatever present inside this bracket will be known as coordination sphere. Everything present inside this bracket is coordination sphere. This outer chlorine is counter ion. This is counter ion. Okay. Whatever the arrangement of the atom in this situation, it will be coordination polyhedra. Polyhedra means different arrangement. Different arrangement. Polyhedra. So this definition is done. Next. Huh. This is important. You have to find out the secondary valence. I will rub this up. How to get to know in this situation? It is saying you have 4 ammonia and 2 chloride, and both the chlorine are forming AgCl. So can we say in this situation all 4 ammonia will be inside and 2 chlorine will be outside? That's why it can form 2 chlorine. So can we say secondary valency will be 4 molecule? In this case, both chlorine are forming AgCl, because remember, mole of AgCl this precipitate. So it means nickel will have how many molecule? 6 water molecule and 2 chlorine outside. So this is octahedral. Now tell me, Sarah, in third compound, how many AgCl is formed? Nothing. So what will be the structure? No chlorine is outside, so everything will be inside the bracket. What
6.
will 6? 2 HCl and 4 chlorine. HCl now it acting as the ligand because it is not coming out. Pratigya, in fourth, if one AgCl is formed, what will be the secondary valency? 1 chlorine outside.
2.
Secondary valency will be 6. 2 chlorine will be inside and 1 chlorine outside. So secondary valency will be 6 because 2 chlorine, 4 ammonia, total 6. Anvita, PtCl2, 2NH3. No AgCl is formed. What will be the secondary valency?
5.
4.
Oh,
Nothing
sorry,
is
yeah, 4,
formed.
4,
So
my bad.
2 chlorine, 2 ammonia.
Yeah.
2 chlorine, 2 ammonia. So all of you are supposed to do all the question like this in your note. It's okay if you don't write some theory, but every single question is extremely important. Okay. You will 100% get question. That's what I believe in every test. If I am giving you test from this chapter, you can expect double salt and complex. So double salt, when you dissolve in water, dissociate in individual ion. Complex, if you dissolve in water, complex sphere or coordination sphere will not dissociate. Anything present in the square bracket will not dissociate further. Outside, counter ion can dissociate easily into the respective ion, but not the anything present inside bracket. Okay, that is the biggest difference. So, what is the difference between these two? In double salt like kernelite, KCl and MgCl2 and 6s2. Mohor salt, iron sulfate and ammonium sulfate. Just focus here, what sulfate? Iron sulfate and ammonium sulfate with 6s2. Potass alum, name suggests potassium. Alum means aluminium. Potassium and aluminium sulfate. Potassium and aluminium sulfate and 12s2. So these are the double salt. What is specialty about these three salts? They dissolve in water and form the respective ion. But if you see here, this FeCN6, it will not produce Cn negative ion. Why? Because anything inside the sphere do not dissociate. Guys, anybody have doubt?
No, sir.
No, sir.
So I am giving you time. Make sure you write all the three names: kernelite, more salt, and Fe. Sorry, more salt and this potassium alum. Done? Let me know once you are done.
Yes, so done.
Every single person is supposed to write this. If you are done, you can write this part, this question.
Done, so
Anybody is left?
Wait, sir.
Yeah. This definition is not important. You need to know central atom is metal and this metal is acid. Why it is Lewis acid? Because it accept electron. You know here it is about the central metal atom and ligand. So ligand donate electron and central metal atom accept the electron. So whatever atom donate electron is base. Atom that accept electron is known as acid. Okay. So Lewis acid accept electron. Lewis base donate electron. Got it? So ligand donate electron. There are different molecules. It could be very small. It could be very big. Even protein can be ligand. Protein can also be ligand. Unidentate ligand means when there is a single donor atom. Two donor atom bidentate. Three donor atom tridentate. Five donor atom pentadentate. Six donor atom hexadentate. So based on the number of donor atom, we use the word dentate or denticity. Okay. Like chlorine, water, and ammonia all are donating one electron, like one donor site, chlorine, oxygen, or nitrogen. So unidentate. If you have two donor atom, didentate or bidentate, both are correct. Didentate or bidentate. How? If you take ethane 1 to diamine ene, both nitrogen can donate its electron, so didentate. Oxalate, both oxygen can donate its electron, that's why bidentate. Okay. If multiple donor atom are present, like in this hexadentate adita, two nitrogen donor atom and four oxygen. Total six donor sites, so hexadentate. Okay. Ethylene diamine tetraacetate ion adita is hexadentate. Ethylene means CH2CH2. Diamine NN. Tetraacetate COO negative 4 times. See, if you see first, you have ethine, ethylene diamine, and how many acetate? Four. Ethylene diamine tetraacetate adita that can form the chelating ligand. Okay. So what is the meaning of chelate? When multiple atom donate their electron to the single metal ion, it is the chelate. How? Example here. If you take chelate in this situation, oxalate, both oxygen are donating to the same atom, form ring. Ring is highly stable, and if ring is highly stable, then it is a chelating complex. Okay. Then it is chelate complex. Okay. And denticity is the same thing. How many donor atom you have? If you have one donor atom, unidenticity. If five donor atom, pentadenticity. As simple as that. If you consider chelating complex, they are highly stable. Why? Ring formation. Okay, ring formation. Last, what is ambidentate ligand? Chandana. Ambidentate ligand means like ambidentate nucleophile. There are two donor site. Example, if you take this nitrito NO2, you know nitrogen can donate electron to the metal or oxygen can donate electron. Though at a time only one is donating, but there are two donor sites. At a time only one is donating, but there are two donor sites. That's why MB, it means dual, two. Any of the atom can donate. Same here. Sulfur can donate electron to the metal or nitrogen can donate. So two donor atom is present in one ligand, but at a time only one donate. Thiocyanate to S through S, and if nitrogen is donating electron. Jordan, what is this coordination number?
So coordination number basically tells us the number of ligands or not ligands,
Not only ligand,
like
denticity.
like denticity,
You
uh,
it do not consider only number of ligand, but consider denticity also.
denticity. Yes, sir.
Example, if you see here in number of ligand is
3,
3,
but then
but
denticity 6.
yes, because each in have two donor site, two nitrogen.
Yes, sir.
Okay, so it is not just coordination number is like number of ligand, but ligand contain donor atom, denticity. Anybody have doubt?
No, sir.
So mention EDTA name, write ambidentate ligand and explain this, focus on this chelating complex. 3 word. Also write this ethane 1,2 diamine again. CH2, CH2, NS2, NS2. Make sure you write this properly. And also write ligand are Lewis base and metal are Lewis acid.
Done, sir.
If everybody is done, coordination sphere is means everything under the bracket is coordination sphere. Polyhedron 3D arrangement, whether it is tetrahedral or octahedral, 3D arrangement is the polyhedron. 3D arrangement. Spatial arrangement means 3D arrangement. Oxidation number charge. You have to calculate how you did in the redox chapter. This word is important, especially like people do ask more in the board, not in me. Ki homoleptic, only one type of ligand. Ki here you have only ammonia. But heteroleptic, you have different type of ligand. See, you have ammonia as well as chlorine. Ammonia as well as chlorine. So different type heteroleptic, same type homoleptic. Okay. IUPAC explain the name of the coordination compound. There are rule. Central atom is listed first. Alphabetical order. Charge does not matter. First letter decide the position. Example, if one letter start with A, second letter start with H, and third start with O. So it means ligand that start with A will return first. Ligand start with A will return first. No space between the ligand and metal atom. But you will understand more through the rule, through the example. IUPAC. Cation is always written first, then anion. If you take negative ligand and with O. Example, if you have oxalato. If you have hydroxide, hydroxido. Chloride, chlorido. Bromide, bromido. Like that. Okay. And no, nitrosyl. These are the neutral. Carbonyl, neutral. H2O, neutral. Amine is neutral. But this amine is special. You know why amine is special? Because you have double M. You have double M, double M, double M. If multiple unit are present of the same thing, then you write bis, tris, tetra, kiss like this name. Reason why. Example, if you have any example, this COEN thrice. You know EN stand for ethane 1,2 diamine. Ethane 1,2 diamine. Correct? If you write here triethane 1,2 diamine, it look like you have three ethane, only two amine, 1 and 2. But if you write tris here, what does it mean? It is the multiplication of complete ethane 1,2 diamine by 3. Whole thing will multiply by 3. Tris. Tris. Understood? Because if you write try instead of tris, you will feel like you are writing together. Yeah. If overall your coordination sphere have negative charge, then metal name will end with it, like cobaltate. Iron will be ferrite. It is written already. Iron will be ferrite. Ag silver will be argentate. Ag silver will be argentate, not silverite, argentate. Neutral name same. Example. This is most important thing. First, you will take positive part. This coordination sphere is positive. How do you know? Because chlorine is negative, then it will be 3 positive. Because 3 chlorine means 3 negative. Correct. Now you have two ligand 1 and ligand 2. For ammonia, you have name amine AMMINE. For water, you have aqua. So both start with A. Now look at the second letter. It is M, this is Q. It means it will start with M. You have 3 amine, so triamine. 3 water, triaqua. Chromium positive, so it will remain chromium. Whatever will be the oxidation number, it will be written in the bracket. And last part counter ion as such. Don't write chlorido. Chlorido will be written only in bracket. Note it down.
So NH3 is 1, right? Like,
And no, you have two
yeah.
ligand done. If example you have two ligand, 1 and 2 means ligand number 1, ligand number 2. So in this case, you want to compare which one will be written first. So
Sir, I'm
AM,
asking the charge about the charge. Like, is it 1 or 0?
charge on ammonia and water is 0.
0, right?
0. Both have 0 charge. Both have 0 charge. Neutral. Both are neutral. If you are done with this, see this. Here it is ethane 1,2 diamine and 3 times. So 3 times ethane 1,2 diamine. That's why tris. You must be asking, sir, why? Answer is if you write triethane 1,2 diamine, then it will consider like you have 3 ethane and only 2 amine. But actually you have total 6 amine in 3 unit. Make sense? To differentiate, we are using different way. Tris.
So what's the charge on EDTA
0, neutral.
and EN?
No. EDTA have 2 negative. En is neutral. EDTA 2 negative. 2 negative overall. Total 6 na. 4 negative, 2 positive. If you see delta, you have total 4 acetate na. So it will be EDTA in 1,2 diamine. If you consider this 2N and 4 negative. 4 negative. Sorry. How? Because 4 oxalate. Sorry, acetate. Why I'm saying again and again? Acetate. Iron. That's why. Understood, guys? 4 acetate ion. That's why 4 negative. I was supposed to take one more J class, but now I have to stop. Reason I'm not able to focus. Move to the next question. If you see here,
What did
by
you
the
say?
way,
I can hear you.
it's okay. I was just saying, yeah, I will not take another class. So, how to calculate charge? You have to compare with the counter ion. Example 1 sulfate have 2 negative. 3 sulfate will have 6 negative. And if 3 sulfate have 6 negative, then these 2 cobalt will have 6 positive. 1 cobalt will be 3 positive. How do I know? Cobalt charge you have to calculate, consider X. So you have 2 cobalt in this unit. Ethane 1,2 diamine is a neutral molecule. So consider as 0. Then you have 3 sulfate and each sulfate have charge 2 negative. Overall, it is a neutral molecule. Overall, every coordination compound will be neutral. So 2x will be plus 6, x will be plus 3. That will be the oxidation number. Exactly in the same way, how you calculate in redox reaction. So this will be really helpful for you. Here, it is interesting. Why? Because if you take this first sphere, this sphere is positive, but second sphere will be negative. It means in first sphere, silver will act as silver. But in second sphere, because overall it is negative, that's why you will have word argentate. Make sense?
Yeah.
Argentate. Why? We said whenever coordination sphere is negative, metal ion name will end with it. So 2 amine diamine, silver. 2 cyanide, so dicyanidose. Negative ion end with O, cyanido. Argentate. But how do I know charge? You have 2 silver. Let's consider every silver X. 2 cyanide. Every cyanide have -1. Understood? That's why in both the silver it will be equally distributed. If you understood this well, look at this. Barinder, what will be the formula of this? Don't write question directly, write answer in your notebook. Tetraamine, 1 aqua water, chlorido, Cl, tetraamine, this, and cobalt with the 3 positive charge and chloride. So you have cobalt with 4 ammonia, 1 water, 1 chloride. And in the end, there will be chlorine. But again, remember here charge on the cobalt is 3. So every chlorine have 1 negative. Cobalt will have 3 positive. It means you need 3 chlorine. Yes or no, guys? Any doubt, guys?
No, sir.
Then Jordan, do B part. First,
K is in the bracket. Potassium tetrahydro oxidozincate. 1 minute, so I'll write it and send you a picture.
correct. So 4 hydroxide, 4 hydroxide OH 4 times. Zinc,
OH4.
zinc.
Yes, sir.
Because it is in negative overall 8. Zinc have 2 positive charge. OH have 4 negative charge. So what should be the number of potassium? Let's take potassium is
It
X.
should.
So 4, no.
No, this is 4 negative. This is
Will
2
be
positive.
2. It
So it
will be
should be
2,
2.
sir.
Because overall it is neutral. Correct?
Yes, sir.
Anvita, C.
So it will be K outside the bracket, then Al C2O4 2 minus 3 times.
K,
Al,
Al.
yeah, and C2O4 2 minus 3 times.
Uh,
And then
what,
negative
what,
charge
what
overall.
should be the potassium number?
Uh,
6 negative, 3
three,
positive.
three.
Correct? Because potassium is also positive.
Yeah, so won't there be like a negative charge on both of them because it's 8? It's an overall
One
charge,
one
right?
oxalate have 2 negative, na? So 3 oxalate will have 6 negative.
No, I'm saying like on overall charge of the whole coordination compound, won't there be a like a minus thing on top?
It will
Because
be minus 3, yes.
yeah, in the
Because
previous
you
one,
have same here. If you have K 2 positive, it will be 2 negative overall.
yeah, we have to write that, right?
Yeah, but you need to know what will be the number of the potassium.
Yeah.
We can't tell what will be the overall charge until unless we don't know what is the number of
Yes.
cation.
Yes.
So what will be the use of this bracket like 2? It will tell us what will be the number of the counterion. Okay, and next, Chandana.
Sir, COCl2, En
CO,
twice,
CO, Cl2, En twice. How many? Nothing else, na? Yeah. What will be the charge? Now you need to calculate charge. Cobalt have 3 positive. Chlorine have 2 negative. Correct? So it means what will be the net charge? 1 positive. Yes or no?
Yes.
Because it should be balanced overall. Done. Uh, Sarah, what will be the answer of E?
Nickel and then 4 times CO.
Done. Charge will be 0 because carbonyl is neutral. Uh, hmm, okay. Hmm, good night. So all these answers are given. Next. Pratigya, A answer. Diamine, chlorido, nitrito, platinum. This is 1 negative. This is 1 negative. It will be 2 positive. Barinder, B. Potassium, space, trioxylato, chromate. Correct? Then in bracket you have to write charge 3. Correct? And also remember that there will be gap after the coordination sphere. Example, tetraamine aqua chlorido cobalt. It is continuous. But you have a gap here between bracket and chloride. Between C, there is a gap. Same gap will be here. Potassium, trioxylato, chromate. Next, Jordan, C. Dichlorido, bis, ethene 1 to diamine, cobalt, bracket 3, space chloride. All of you understood how to do this? Any doubt, guys? Every
No,
NCERT
sir.
question is important.
No, sir.
Then isomerism. First, we will do linkage isomer because easy to do. Like all these kind of isomer, structural. So what will happen in case of structural isomer? Compound formula is same. Something is different in the structure. Example, if you take the linkage isomer, it means compound formula is same, but linkage is different. Example, in NCS, sulfur is forming bond. In NCS, sorry, nitrogen is forming bond. In SCN, sulfur is bond, forming bond. Okay. So same atom, but bonding site is different. Such ligand are known as ambidendant ligand. Ligand that have two donor atom, but at a time only one donate. Jorgensen was the guy who discovered the behavior of this. Example, here nitrogen is forming bond, and if there is a binding with the help of oxygen, it will be red color. And if it is a binding through the nitrogen, then yellow color. So everything is same, but because bonding site is different, color is also different. ONO is forming red color and NO2 is forming yellow color. Why? Linkage is different in ambidextrous ligand. Coordination isomerism. If you see here, cobalt is present with ammonia and chromium is present with CN. Here, chromium is present with ammonia and cobalt present with CN. Ulta, opposite. Why? Coordination sphere is different. Coordination sphere is different. And there is an exchange of ligand. Exchange of ligand. Ionization isomer. When ion is different. Example, in first molecule, Br is ion, counter ion. In second situation, sulfate is the counter ion. In first situation, bromine is the counter ion. In second, sulfate is the counter ion. Understood? Last, solvate or hydrate. Why it is called hydrate? Because water molecule are different. Example, here all water molecule are present inside. It is violet in color. But here one water is outside, so gray green. Colors change because of the number of water molecule are different. Number of water molecule are different. And it is almost same as the ionization isomer, but only for water. Tell me guys, was it difficult?
No, sir.
Yes.
So just in 1 hour we covered a lot of thing, and after that it will be directly valence bond theory and crystal field theory. But we are also left with this, where you face more difficulty because it is isomerism. So isomerism means we are talking about stereoisomerism. Chandana, what is stereoisomerism?
So different spatial arrangements.
Yes, 3D arrangement is different. Structure means structure is different. We already studied. Linkage in ambidextrous ligand. Coordination means ligand will exchange with metal. Ionization, ion is different. Solvate means water molecule are different. In stereoisomerism, geometrical cis or trans, optical D or L. Example, if you have different type of isomer, example this is with coordination number 4. Example, in square planar compound, it could be cis or trans. Example, in case of cis, chlorine are same side, ammonia are same side. In trans, ammonia are opposite side. Correct? Trans. Done. If you take all different molecule A, B, C, D, all are different. In this case, you will see 2 cis and 1 trans. If all are different, it's like you can compare EZ configuration. Do you remember EZ configuration?
Yes, sir.
In EZ, there could be different atoms. Then you compare with the heavier. If heavy atom are same side, it is like E and opposite side Z. Correct? But remember, it is not possible in the tetrahedral geometry. Sarah, why? Equal arrangement. Whatever you do in tetrahedral, everything looks similar in geometry tetrahedral. Okay, everything will look exactly similar. Understood? Everything look exactly similar in tetrahedral, even after rotation. In octahedral, example, if you see here, if chlorine are opposite to each other, trans. If chlorine are present same side, cis. Same side, cis, opposite side, trans. Done. Same thing here. You have didentate ligand. If chlorine are same side, ene are same side, cis. If ene are opposite side, trans, or Cl opposite side, trans. Okay. Opposite side, trans. Same side, cis. Cis and trans. This one. Here, if you have Ma3B3 like this, what will happen if in case of phase, all three molecules will be present on the same side? And in case of mer is like trans, ammonia, ammonia opposite side, NO2, NO2 opposite side. Understood? If they are opposite side, it is like mer. Mer means like trans. Phase means like cis. Ammonia, ammonia. Okay, phase is more like cis, and mer is more like trans. Done. And in doubt, guys, same thing is given. Why geometrical isomerism is not possible in the tetrahedral complex? Because relative position remains same. Doesn't matter how you rotate, still it will remain same. Anybody have doubt in geometrical isomerism, cis or trans? Phase or mer, facial and meridional. Last topic for today is the optical isomer. If they are mirror image of each other and they are not fit into each other, they are enantiomers. Enantiomer means mirror image but not fit into each other. Chiral means all atoms are different. What happened? Chiral means all the four atoms around the carbon is different. It could be D or L in an enantiomer. One will be D, another will be L. One will be D, another will be L. You will see ki example in this case, EtCl2, En2. Only cis will be optically active. Trans will cancel out each other. Example, these two both are cis. See, cis, cis, mirror image of each other. So you will, in the cis isomer, you have optical activity. In trans, what will happen? There is complete symmetry and it will not be trans. In case of trans, it will not be active. Example, you have platinum, one chlorine up, one chlorine this, one En this, another En is this. What will happen? They will cancel each other. Is it symmetrical? Yes. Wherever you have symmetry, you don't have optical activity. Make sense, guys?
Yes, sir.
Yes, sir.
Yes.
Yeah.
Yes, sir.
Wherever you have symmetry, no optical activity. This will be like D. D is dextrose right, chlorine is right. Here chlorine is left, L. DL form. Isomer in this case, cis, any side. Trans, opposite to each other. Trans. Optically active. Cis is optically active. What will happen in case of cis? Same side. But trans, optically inactive. because net will be zero, optically inactive. Net zero symmetry means no chiral compound. That was it too tough to understand anything?
Not at all, sir.
Yeah, we just took one less than hour, not less than like 1 hour, and we finish everything. In next one, not 1 hour, maximum 1.5 hour, we'll finish this chapter. But as I always mention, quickly revise for 10 minutes, then we will solve question of this chapter.